Alright, bet. Today we're going to be talking about electrokinetics part 3 and concentration polarization. So concentration polarization is basically when your corrosion rate hits a speed limit, right? It like corrosion just stops. So yeah, so yesterday's video was more about the energy barrier of the reaction itself. Today's more about what happens when the diffusion of reactants, like oxygen most of the time, can't keep up with the demand at the metal surface. So let's begin. Consumption. When corrosion happens, the metal kind of eats at the reactants in the water right next to it. So you got the metal and you got some water on top. It eats at the oxygen molecules on top of the water. Then now there's a gap. Because of those reactants that it eats up, there's a low concentration of oxygen molecules here. There's a higher one, like more in the bulk of the liquid, right? So now there's a imbalance. So there needs to be diffusion. Diffusion is basically when particles move from high concentration to low concentration. So it needs to move from the bulk of the liquid, the high concentration, to where it eats up the site of corrosion, the low concentration. But since there's a bottleneck now and diffusion is slow, right? To go from high to low, it's slow. It's a bottleneck. So the corrosion reaction happens really fast. It consumes the reactants as soon as they arrive. But now it's kind of like in idle, it kind of stop moving. So there's a formula to break down what I'm talking about. So let me show you. All right, this is a formula. So this is the limiting current, um, limiting current diffusion density, right? This is what IL is. Basically just corrosion rate. So D is the diffusion rate, how fast it goes from high to low particles, right? If it goes really fast, the corrosion rate goes really fast. So you can keep corroding. And it's just the electrons transferred. F is like the Faraday's constant. It doesn't really matter, it's just constant. And CB is the bulk of the liquid, right? How many reactants are there in the whole liquid? So the more of it, the more corrosion, the faster the corrosion rate. And then on the bottom here is the diffusion layer thickness of the water, thickness of the water, of the stagnant water, the water that isn't moving. The thicker the water, um, the higher this number, the lower the corrosion rate. So corrosion rate could be like zero almost. Like, so imagine the numerator is one divided by 100. Imagine one chocolate bar divided by 100 people. So each person gets like such a tiny bit, like probably it'll be like 0.1, right? 1 divided by 100 is 0.01 actually. But imagine this is number one. 100 divided by 1 is 100, so this would be a faster corrosion rate. So, um, thank you for watching my video, I guess, and that was activation polarization.